What if you fell into a red dwarf? Red dwarfs are small, hot balls of burning plasma that make up 75% of the stars in our galaxy. And although they are big, they also have very strong gravitational pulls, which could be enough to trap you forever. So, what would happen if somehow you found yourself hurtling towards a red dwarf? To answer that question, we lions have to take a trip about 4 light years away from Earth to the Alpha Centauri system. This is the closest neighboring star system to ours, but unlike our Sun, it has not 1 but 3 stars. The brightest of these 3 stars is Alpha Centauri, which is almost identical to our Sun. But orbiting this star is another star called Proxima Centauri, which is about half the mass of our Sun and is the closest star to us outside of our solar system. Because Proxima Centauri is so close, we can actually see it with the naked eye as a faint point of light between the stars of Orion and the Bull. It may seem like just a regular star, but don't be fooled because Proxima Centauri is actually classified as a red dwarf. Red dwarfs get their name from the fact that when viewed from Earth, they appear red. This is because they are literally red in color like a ripe strawberry or the skin of an apple. Instead, it is because of a phenomenon known as the Doppler shift. Red dwarfs tend to move faster than bigger stars, and as a result, their light gets stretched out, shifting it further down the electromagnetic spectrum until it becomes visible to our eyes as red light. To add to that, the size of these stars is so tiny compared to the Sun that they look like pinpoints of light unless you are very close to them. Also, all stars emit light at different temperatures depending on their surface color. As a general rule of thumb, the cooler the star, the more red it appears. Since red dwarfs have surface temperatures around 2,400 degrees Celsius, they fall on the cooler end of the spectrum. But just because red dwarfs are small doesn't mean they aren't powerful. These compact stars pack a lot of mass and consequently have intense gravitational fields. In fact, most of these stars are so dense that if you were to squeeze our Sun to the size of a red dwarf, its gravity would become thousands of times stronger. That means if you were anywhere near a red dwarf, you would feel its gravity pulling you towards it from miles away. It's no wonder astronomers have nicknamed them gravitational vampires, since they mercilessly suck in anything that strays too close. To find out how far away you need to be from a red dwarf before you start feeling its gravitational pull, let's take a closer look at our galactic neighbor, Proxima Centauri. If you were somewhere between 10 and 100 kilometers away from this star, you would experience a gravitational pull similar to the Earth's gravity. However, as soon as you got within 3 kilometers of the star, the gravity would become thousands of times stronger than Earth's gravity and would increase even more the closer you got. At 1 kilometer from the surface, you would experience a gravitational pull over 100,000 times that of Earth's gravity. By the time you were only 30 centimeters away from being crushed by the intense pressure of the star, the gravity would be over 60 million times greater than Earth's gravity. It's safe to say you wouldn't survive that kind of gravitational force. You would be utterly crushed into a pancake. However, there is some good news. The surface of a red dwarf is not where the action is. There is an area surrounding the star known as the Roche limit. In astronomy, the Roche limit refers to the distance from a celestial body at which a spacecraft or other object will break apart due to the tidal forces of the gravitational pull. Every large space body like a planet or a star creates a gravitational pull. And as you approach that body, the gravitational pull gets stronger and stronger until eventually it becomes so strong that it tears your spaceship apart. For reference, if you were to enter the Roche limit of Earth, you would be torn to shreds by the gravitational forces. Now imagine approaching a red dwarf. Its gravitational pull would start to affect you much earlier than the surface because these stars have such intense gravitational pulls. For example, if you entered the Roche limit of Proxima Centauri while standing next to it, you would be ripped to pieces. But if you were further away, you would still be affected by the tidal forces long before you reached the star's surface. Even if you managed to avoid being ripped apart by the Roche limit, Getting too close to a red dwarf can still be dangerous. As you get closer to the star, the intense heat would burn your spaceship, leaving you exposed. Then the gravitational pull would start to take its toll, crushing you and stretching you until you were nothing but a pile of space dust. In fact, if you got close enough to a red dwarf, the gravitational pull would actually start to drag you towards the star's surface even if you tried to fly away. It would be like trying to escape a black hole, except instead of falling into an invisible abyss, you would be pulled towards a searing ball of burning plasma. But there might be a way for you to escape this fiery fate. If you were traveling at high speeds when you approached the red dwarf, you might be able to use the star's gravity to slingshot yourself away. This is known as a gravity assist, and it is a technique that has been used by spacecraft for decades to speed themselves up without having to carry a lot of fuel. The idea is that instead of burning fuel, a spacecraft can use the gravity of a planet or star to accelerate itself. For example, NASA's Voyager 2 spacecraft used a gravity assist from Jupiter in 1979 to help it on its way to the outer planets of the solar system. Without that gravity assist, Voyager 2 would not have had enough speed to reach Neptune and Uranus. Unfortunately, even if you tried to use a gravity assist to escape from a red dwarf, it probably wouldn't work. The reason is that red dwarfs have such strong gravitational pulls that you would have to be traveling at incredibly high speeds to free yourself from their grasp. For example, if you were in orbit around Proxima Centauri and wanted to escape its gravitational pull, you would need to be traveling at over 250 kilometers per second. That's fast enough to go from New York to Los Angeles in less than 2 minutes. Even if you were able to build a spaceship that could withstand the incredible G-forces involved in a gravity assist from a red dwarf, it's unlikely that you would be able to control it once you started falling. That's because red dwarfs emit huge amounts of stellar winds that could easily knock your spaceship off course. Once you started falling towards the star, it would be very difficult to steer and you might end up crashing into the surface. But wait, there's more. Even if you managed to escape the gravitational pull of the red dwarf, you would still be stuck in the Roche limit. Remember the part of the video where we talked about how the gravitational pull of the red dwarf would tear your spaceship apart? Well, that would still be a problem. You would need to find a way to get out of the Roche limit before your ship was torn to pieces. Otherwise, you would be trapped in the star system forever. So, what would you do in this situation? Would you try to escape the red dwarf's gravity, or would you try to find a way to survive on a planet in the system? Let us know in the comments below, and don't forget to stay tuned for more videos about space. We have made the assumption that you are falling into a single red dwarf. However, many red dwarfs exist in binary or multiple star systems. That means there would be at least one other star nearby that you could potentially use to escape. In that case, your best bet would be to navigate your spaceship between the two stars and use their gravitational pulls to slingshot yourself to freedom. But that would be much easier said than done, since the gravitational pulls of both stars would be trying to pull you towards them, and even a small miscalculation could spell disaster for you. So count yourself lucky. You managed to escape the red dwarf, and now you find yourself hurtling through the vast expanse of interstellar space. But this journey has taken a toll on you and you're starting to run low on resources. Luckily, there is a gas giant in the system that you could potentially land on for some much-needed supplies. But as you approach the planet, you notice that it's covered in massive storms and turbulent winds. Don't worry, we have you covered with our video on what would happen if you landed on a gas giant. So make sure to check it out after this. Thanks for watching.